Welcome again to Wickerson Studios. My name is Michael Wickerson, and I am going even farther into Rajaa Issa's Essentials of C# Scripting. And I have grabbed a one render of 3 scripts, and you can see that the geometries are not that complex, but I'll be generating and taking a look at them in here. And there's a couple of things going on here, and I've got all these scripts running. Let me get rid of this one. Actually, I took these ones off. We'll be looking at those and having a peek at list items, item access, list access, and tree access. But the sample that comes out of it that I tried to visualize was this one, which was pretty simple. I internalized 2 curves. I divided them. I ran it through a C script, and then I just drew lines between them. So very similar to one of David Rutten's first scripts to learn Grasshopper. The script itself is fairly simple. You can see here that basically I have kept everything to item access points, and that should say everything here. Point, all points. I did input a radius, and I have all spheres as the reference object. Then spheres, I'm generating a type sphere for point sphere, which equals a new sphere at all points at radius, center all points and radius set to that. And then I'm listing the item access runs. And this is where I've done a little correction because it doesn't make sense saying writing it runs 0 times. If I just go in here and I've changed all the other scripts to this, I better do it. Iteration +1. That should help us understand that a little better as I run it. So there you go. It's running 1 to 2 times, 3 times, 4 times, 5 times, 6 times, 7 times. It's going through each of the spheres and running through them. And that's kind of how list access, single access works, which isn't the most efficient if you want to deal in lists to calculate things as a whole, or even get into data trees. So let's close that one out, and I will take that one and put that one on disable because we're not going to use it. We'll go into what I wanted to do, and we'll take this, and those can disappear because I've actually have them internalized as the curves. So what I have are these 3 scripts, and here they are, 1, 2, 3. And they're all running the same, and they're all running off of the same sense of how many divides I'm doing. I'm actually dividing the curve just one way, and we'll go into here, and since they're all flowing into the same type of thing, if I make this preview on, you're going to see all the forms as they go. And what dictates that? So item access, if we took this off and we disabled all of these, because they're all running through the same merge, here are our points. And what is actually happening there is I have a C script that's being run from a gene pool that takes a I'll put this on so you can see it. Takes a quad sphere, divides the edges up, finds the edges, and then I've got a quad here that I can randomize and grab another 2 edges. I can grab it, you slide it out like this if you want to. It's just like double number sliders, picking the list item, which I kind of like to do. And then it divides those into points, and I've got them divided into divided 1 time, 2 times, or 3 times. So if you see the 3 divide, then you're ending up with all these points, all these circles that are on there, spheres that are on there. And then what I did was I just did a radius that was kept parametric through the radius of the rods, and I changed that a little bit, divided it by 2 in this one, divided it by 3 in this one, I think, and divided it by nothing in the last one, or just set to 1. So what happens is the script runs, and here it is, in list access, and the real key thing here to understand is not all the geometry afterwards. It's the same structure that I just showed you through the iterations. And I'll pull this down like this so you can see that, and you can see the geometries. But really, the main thing is noticing that if you do a list item, it's going to run 1, 2, 3, 4, 5, 6, 7, 8 as many times as there are spheres on it. So in that happening, then I also outputted, sorry for this, it's a little confusing. I also divided point outputs, point underscore out as points, so that I can just run those into pipes, and you could do variable pipes if you want to make it look more exciting. So that's that one. That's a little different than the other one. The main thing is if that script runs, it's going to run it a single time for each one. So as many spheres as there are, you're going to get as many iterations that run. And that's just the way it works when you deal with item access. And you can change this up by going here, randomizing that form, and having it shoot over here. Interesting little single item there that popped up. Over here, you've got another one. And you can go back and you can change the count if you wanted to down to 2, which will simplify it, and down to 1, and that would simplify it as well. I'm going to leave it at 2 because that seems the easiest to kind of understand and see what's going on. So that's the script for item access. If we go on to list access, so we'll have to take this one off and turn that to disable, and then take this one on and put this to enable. You can see that this one, if we take a look at it right here, something's gone wrong. Oh, because I deactivated this. I have to leave that enabling. So now what we have is the same type of thing, same structure, grabbing a quad sphere. There it is, grabbing the lines to it. And I just have to click on it if I want to see it. Sorry. Um, okay, I've got sphere. I've got the edges. I've got the lines that are the curves that are coming out of that. I'm dividing them by 2. I'm setting my gene pool, which is a tool I really like to use for multiple sliders, and then I run it into the script. And what's happening different here is the main thing is right here, and we're doing the same geometries to it afterwards. If you take a look at this, it's running one list one time and one list the second time, which is basically treating them as separate curves. And how that's working, here's the script to it. It's a little more complex, so we'll go into it and we'll take a look, and I'll probably move it over here so we can see it. You're going to have to create a list type sphere, which will be that list, and then the list will be set to a loop list sphere, and then for each point on each of those point lists, on each of those curves, you're going to generate a sphere at those points with that radius that you've set. And I actually brought in, obviously, a different radius, so we'll just change it up a little bit. And then I'm printing the access runs iteration +1 that many times, and then I've outputted sphere list, and point list out here. And so then you can see the main difference in these two scripts dealing with lists and dealing with items are this is a list access, runs 1 time, and then it runs again 2 times, depending on how many curves there are. And that's how that script's running. Of course, that alters from the one that was above that was running them each and every time. Now, the most advanced one, I guess the third little pig that's smart enough to kind of put out its home in a brick house, we'll close that out. We'll come down here, we'll turn this one to disable, and then we'll run this one on enabling. And the main thing here is everything's running the same again. You've got your end geometries that are here. They're being dictated, obviously, again, by the size of the sphere, which you play with, a randomness of the gene pool, and picking through everything. And then C script, I've changed the scale. I divided it by 3. I guess this one, if I wanted the pipes to be really tiny, maybe I'll just leave it at 1. I won't even divide it. I'll just take that and have it go in as a single radius. We should divide it by something. Sorry, I'm getting a little confused here. Let's just divide it by 4, and that will shrink that down a little more, so it's a little more emphasized. And the script here is running the tree access has 1 iteration, and this is where things get really complex and you want to wrap your mind around it. So you open this up, and even though we're dealing in the exact same geometries and the same script inside and out of that node, the C script changes so much. So we have to declare a tree of spheres. So the type is data tree spheres, and that's a sphere tree, and there's the new data tree sphere. The index path has to be initialized as an integer, so you have to deal in a path index, and then for each list point in the branch of those PT tree branches, you're going to list the sphere, and this is where you tuck the last script list into this tree list. So it starts to make a little sense as you nest it in, but you've got to go in and use the path and set the path, which is another type, the grasshopper path, to the GH path at that path index, which you've initialized at 0. And then you're going to roll that through +1 until it ends, obviously, with what I believe to be the last branch of that tree. And then you've also got to nest in. What you've done is an item access right off the bat, which was for each loop point in branch, you're going to set a sphere up there. So you kind of see it visually as you tuck, and I probably could have left my script up here and commented it out of the ones before, because it's literally just a boxing and a boxing and a boxing of things into one another, and then I'm turning it out. Now, I didn't at this point produce a points out, and I guess I could have written in the C script. I decided, well, what the heck, if I have the spheres, I'll just throw it in here and grab a centroid and just use one of the nodes I know well in Grasshopper. And that's where I think people will be interested in what I'm doing, because I'm learning the script, but I'm staying very much dependent on how I sculpted and how I made things and designed things in Grasshopper. So hopefully there's a middle ground of how far you want to go into C script, how much you want to wrap your head around it. and how much you, and actually it should be easier to wrap your head around trees, if not lists, than single items. And then all of a sudden your wonderful wires, this fancy wire display that has always caused you a little bit of questions, starts to make an awful lot more sense. So in the end, after I run them all, I'm able to take them all out, put them all into the same one. They all should be behaving differently. And of course, I have to take them all on and make them visible and enable them. Hopefully I've done that. I probably shouldn't have made everything visible, but this is our structure itself tucked into all that information. Let's get out all that other visible stuff. And then there's our end of what we've actually produced. And you can get in here and play with it. You can jostle up your little gene pools, randomize them. That's going to change them. That one changed so much because 12 and 0 are actually the same. So that would not be good to edit this. I should probably have this set to 11 so that doesn't happen. And so you start to understand your geometries. And we'll just go in here and do a little random 10%, which doesn't really matter because they're such small integer numbers. You can also move things around a little bit. I like it because it's starting to make a little more sense to what I'm doing. And as I figure these out, I believe that I'm just going to bake these. I'm talking out loud. Bake them into here. You get a pretty nice form as it runs through the technical. It's not much of a structure, but if you think about that being produced, what you can do now, probably that would be more interesting, is go up and take this iteration up of dividing it. And that does make a little bit of difference as we go in here. So watch what happens. If I'm not pairing the other lines, you'll see you're producing a few more spots. There's 3 on the divide, and you're left with some. Well, it worked pretty good, actually. They all joined together again. Let me take this one up and see if I can take it up to a 4 or 5 count, which might be a little higher than I want to go. Max 5. Let's just slide up here and see what happens when we divide it a little more. There we go. So you're getting this pretty intricate little form that's dancing around and doing what you wanted it to do with connecting lines throughout each of the cases. And then let's take that one up again to 5, and there we go. We kind of got nuts on it. So pretty interesting little form to roll around and think of that geometrically. And that's produced by considering item access, list access, and tree access with some scripts that you can cut and paste if you don't fully understand them, but get into here and try and have some fun with it. It can be pretty cool. All right. Thanks very much for watching. I think I'll zoom out. Obviously, we're going to continue, and this time we're going to actually learn and go in and learn how to set data trees, pull data trees from C# nodes. So thanks for watching. 13 minutes.